Hello, students. I'm Dr. Kusum and presently working as a professor and head in the Department of Electrical and Electronics Engineering at ABES Engineering College. And I'm here to present the lectures of electric vehicle technologies. So, electric vehicle technologies has been one of the emerging area in the domain of electrical and electronics engineering, where we can say the present internal combustion engine technology, which is the automobile engineering, it is going to be changed, or it is going to be replaced by the electric vehicles in the coming time. So, on that note, recently our uh, cabinet minister, Mr. Nitin Gadkari, he has also said that there are almost 30 million jobs which are going to be available by 2030 when in the domain of electric vehicle technologies. And therefore, this is the area which is quite interesting as well as quite promising in the domain of electrical and electronics engineering. So here I would be recording these lectures in this EV technologies, and this would be helpful for all the students, those who have opted for this particular elective, which has been offered by the department in the 7th semester. And even though those who haven't opted for it, but they just wanted to learn about it, and the student may be from second year, third year, or even in the final year. So they just wanted to learn about this technology, and they just wanted to develop their own skills in this direction. So this course will be very helpful to them. So I would just like to tell you the course outline. So the outline of the course, in the first segment, it will tell you about the overview of the electric vehicle in India. So what are the prospectus and what are the future plans, and overall how we can see this technology in the perspective of India. Then vehicle dynamics. So here vehicle dynamics is basically, it is going to tell you that what are the acting forces on the vehicle when it is in motion, and then how the range of the vehicle has been needs to be calculated. So all that dynamic part of the vehicle will be discussed in this segment. Then vehicle subsystem, which includes the powertrain and the accessories. So powertrain is basically the power transferring assembly, which transfers the power developed by the electric motor to the parts where it is required. And presently, in the automobile, this power is being generated by the internal combustion engine. Then fourth is the very important part of this particular course, which is talking about the storage of electric vehicle. So storage is major, energy storage is presently in the form of batteries. And in future, we can see the battery may be replaced, or battery are going to be replaced by the fuel cell technology. So that we would be discussing in the times to come. But of course, the storage of the energy storage of the electric vehicle, it is again one of the important aspect of the electric vehicle. Then the fundamental of the EV battery pack design. Then the motor, which is the prime mover for the complete EV. How this motor, or what kind of motors are being utilized along with their controllers, what are their fundamentals and how these can be designed. And then we would be talking about the battery charging and the swapping mechanism. So how the battery is charged commercially, or the battery can be charged domestically. And even when the battery charging time is not available, then how the swapping mechanism can take place. Just like we used to get our fuel filled at the filling stations. So that is all about that will be discussed in the seventh part of the course. And last one is the management of the EV infrastructure. Since this is the one of the important initiative by the government of India. So how this EV complete infrastructure is going to be managed. So that would be talking in the last. So firstly, I would just like to ask one question. So question is, why so much of interest in the EVs? So we all talks about EV, we superficially know about that EVs are going to be the future of the automobile industry. But what are the facts behind it? So the facts are like why EV is or why the people are trying to convert all their internal combustion engine into the electric vehicle. So the important facts about the air pollution, specifically with related to India, that out of 20 most polluted cities in the world, 14 cities are belong or 14 cities belong to India. So that is one of the concern in the mind of government of India, that the level of pollution is very high in India, and that makes us to think about that how this pollution can be controlled in the metro cities specifically. Uh, we know the major of the air pollution, it is contributed by the transport sector, where majority the IC engines are working. So 36% of the NOx emissions are due to the vehicles. And if these vehicles are replaced by the electric vehicles, then definitely this percentage is going to be reduced by a drastic amount. Then in the 20% of particulate matter 2.5 emission, specifically in Delhi, because in Delhi, we see the kind of situation that especially during the winters, it becomes a kind of smog city where we can see the particulate matter 2.5 very easily in the air, and it is very poor quality of air is available for breathing purposes in specifically in Delhi. And this 20% of this PM 2.5 emission is due to the vehicles. We have already also seen that government has taken the initiative of odd and even kind of numbers, that in week times, in one day odd vehicles would run and another day the even vehicles, but that has not worked well. But during the COVID, when there was a complete lockdown for several months in India, at that time we have clearly seen that the quality of air has been improved like anything, and that was majorly because of the factor that the vehicles were not moving at that time. Majority of the vehicles were not moving. So here are the facts. Along with that, uh, the fact of air pollution, the second fact is the major currency of the India is going out on the purchase of crude oil. And this purchase of crude oil has been almost 40 times uh, increased from the 1981 to 2015. So there is an increase of almost amount 40 times from the 1981, that is almost in 35 years, last 35 years. So petroleum consumption, it has all increased from 32.5 million tons in 1981 to 184.7 million tons in 2015. So if we just wanted to make just reduce our imports, then it is very wise decision that we should shift on the electric vehicles. So it will reduce the oil consumption or the crude oil import, and this is how we can save our money to go out. And the honorable Prime Minister of India, he has given the target that when the India would be completing their 100th year of independence, that is by 2047, India would be included in the developed countries. And for becoming a developed country, we need to uh, increase our exports and reduce our imports. So reducing the import, there the crude oil is the one of the major entity, and this crude oil import can be reduced only by shifting present transportation industry from automobile to the electric vehicle. This makes the whole technology is so interesting, so evolving in the present time that we all should learn about that. And these are the important factors that in order to reduce the pollution, as well as in order to reduce the oil imports, or in order to reduce our overall imports, the EV is a very wise option. Then, along with these facts, we can also see that electric vehicle is nearly 4 times energy efficient than the internal combustion engine. So, internal combustion engine, there the fuel is being burnt, and then the thermal energy, it is converted into the mechanical energy by the virtue of internal combustion engine, and therefore the overall conversion efficiency, it nearly comes around 22 to 23%. Whereas in electric vehicle, the chemical energy which is stored in the battery, it is converted into electrical energy by the action of battery, and then the electric energy is directly converted into the mechanical energy by the motor. And here the overall conversion efficiency, it comes around 90%. So here we can see the EVs are almost 4 times more energy efficient than the internal combustion engines. At the same time, the electric vehicles are having the 50 times less moving parts, which means that the life of electric vehicle would be much more than the internal corresponding IC engine based vehicle, because it is having 50 times less moving part in comparison of an IC engine based vehicle. So here makes this EV technology so interesting for everyone that we should learn about it, and we should be the part of this evolving industry. Now, here previously we discussed about that this is why we should switch to this EV, but we haven't yet. So the question is, where is the problem? So if the EV industry has been so lucrative, or it has been so promising, then why we are not switching to EV yet? What are the problems, or what are the challenges? So challenges majorly on the energy storage part. So if we just compare, we first need to understand that what we mean by the energy storage. So in order to understand the energy storage, we need to understand two terms, which is called as gravitational energy density, which is measured in watt hours per kilogram. That means corresponding to 1 kilogram of fuel, how much watt hours would be generated. Watt hour is an electrical unit of the energy. So it is the unit of energy. Unit of energy is joule, or joule unit of energy is watt hour. So in the electric vehicle, we would be using the unit of energy in terms of watt hour. So what is the basically unit of power? And then when power is multiplied by the time, it is converted into the energy. So the gravitational energy density, it indicates that how much or how many watt hours can be generated by a 1 kilogram of the fuel. Similarly, the volumetric energy density, it is giving you the value of watt hours per liter. Specifically, it is for the liquid fuels. So the in the internal combustion engine, majorly we are using the fuels diesel, petrol, and these are the liquid fuels. So there the energy density, that is volumetric energy density, it is more important. So here there is an assignment, or it's a kind of little work to do on the Google itself, that first you need to see that from the traditional fuels, that is wood, coal, then petrol, diesel, and then the energy which is stored in the battery, and the future of the battery is fuel cell. So all these fuels, right from the traditional ones, coal, wood, petrol, then electric battery, and then fuel cell. So what are the values of what are per kilogram, and what are per liter if the fuel has been a liquid fuel, then of course the energy density would be measured in watt hour per liter. And if it is solid fuel, then it will be measured in watt hour per kilometer per kilogram. So I hope you are already acquainted with the unit of energy that we have already talked about, that watt hour and how this watt hour is being defined. So for the electrical metering, the 1 unit of electricity, it is corresponding to 1 kilowatt hour. That means 1,000 watts. When they are 1,000 watts are continuously being utilized for 1 hour, then the power consumption is 1 kilowatt hour, which is the basic unit of electricity. So in the small Indian homes, the usual consumption of electricity or electrical energy is 2 units per day. So these are the general facts. So if we see the data that presently, what are the energy density which is being offered in the battery? So in battery, the in LF, NMC and NCA cell, the gravitational energy density, because battery, it's a solid fuel. So the energy, although battery is being recharged, so the energy density, it is 250 to 300 watt hours per kilogram as of today. Then in the coming time, as there is continuous development on the battery technology, the scientists are working tirelessly on the battery technology. And therefore, we can expect this count can become 400 to 500 watt hour per kilogram in the coming years with the NMC with graphite silica anode. So with these kind of development, when they will be available in the commercial segment, the energy density can go up to this. Similarly, for NMC cells, the volumetric energy density, it is 500 watt hour per liter. It is also 500 watt hour per kilogram. So it is almost similar kind of. The battery can have the higher energy density, but there are safety concerns. So beyond a particular limit, the energy density might not be increased for a battery technology. And therefore, the promising technology on the part of energy storage it is uh, fuel cell technology, which is also known as green hydrogen technology. So you have heard this term quite often in various policies of the government, that we are promoting the green hydrogen technology. So green hydrogen technology is nothing but the fuel cell technology. So we are not discussing this technology right now, but of course, with the due course of time in this particular course itself, we would be talking about the fuel cell technology to little more length. So here there are facts like in 2011, the energy density was 80 watt hours per kilogram. And then by 2020, it becomes 310 watt hours per kilogram, which is almost 4 times of what we had in 2011. And we are even anticipating that in the coming time, it will go up to 500 watt hours per kilogram. At the same time, the cost of cell, it is also reducing continuously. So the cost of cell, which has been $800 in the world market, now it has been $110 by the 2020, and it is further likely to go down as the technology would be utilized by more and more members. This particular price of cell will go down further. So here we can just see. Now we just compare. Now, presently, if I see the energy density, it is going around 300 watt hours per kilogram or 400 watt hours per liter. In comparison to this, if I see the petrol energy density, so petrol energy density, it is 12500 watt hours per kilogram. That means almost 12.5 kWh per kilogram. So it is almost 10 to 12 times more than the, if I compare the 500 watt hours. So if I just compare that for battery technology, presently this is I'm just using marker. I think that would be helpful. So for battery, I think the present value is 300 watt hours per kilogram. And what we are having for the petrol, it is 12500 per kilogram. So if I compare the energy density, gravitational energy density of petrol and the battery, so it is petrol upon battery. So here it would be 12500 upon 300, because it is likely to go up around 500, but presently this is not 500. So here we can see the this is almost 4 and 41.6. So it is nearly 41.6 times more than the battery energy storage. So even if we count upon the 4 times higher efficiency, so the energy efficiency of electric vehicle is 4 times. So even if the efficiency, the conversion efficiency, meta conversion, it is 4 times. It is 4 times of the ICE technology. Then also the weight of battery per kilometer required would be 10 to 12 times higher than the corresponding weight of petrol. So if suppose a vehicle has to go for 100 kilometers, then if I say that the mileage of vehicle is 15 kilometer per liter, 15 kilometer per liter, then for running the vehicle for 100 kilometer, we require almost 6.67 liter of the fuel. So if I consider the energy the density of the petrol is 0.7 kg per liter, then the almost weight of the petrol, it comes around to 4.5 kg. So 4.5 kg of the petrol would be required for making the vehicle run for 100 kilometers. But if we just see the value, I'm just taking to the next. This is a kind of assignment we can just see, or we can just see that how this can be. So here I'm saying that the vehicle is having the mileage, it is 15 kilometer per liter. So if I'm trying to make the vehicle to run for 100 kilometer, for 100 kilometer, how much petrol would be required? 100 upon 15. So it is 6.67 liter. Right? Now, 6.67 liter, if it is converted into kg, so 6.67 liter into nearly 0.7 kg per liter. It is the density, volumetric density of the petrol. So it comes around nearly 4.5 kg of the fuel. Kg of fuel. Fuel is petrol. Now, if I compare that how much kilogram is required, like for battery per kilogram, 250 watt hours can be developed, can be generated. And for 1 kilometer, how much watt hours are required? So, just like for 100 kilometer, how much watt hours would be generated? Required 150 into 100. Because for running the vehicle at 1 kilometer, we require 150 watt hours. So it requires 150 into 100, that is 15000 watt hours or we can write it 15 kWh, 15 units of the electricity. I hope you remember the basic unit of electricity, or that is 1 kWh. So it is 15 kWh. Now, you just see that the weight is 250 watt hours per kilogram. So corresponding to 1 kilogram, there is an energy of 250 kilogram. So how much, or kg, or weight of battery, weight of battery. So what will be the battery weight for it? So battery weight would be 15000 divided by 250 watt hours per kilogram. So it becomes 60 kg. Now you see the weight of battery is 60 kg and how much fuel was 4.5 kg. So you just see the comparison that for making the vehicle to run for 100 kilometers, the weight of petrol would be 4.5 kg and 60 kg battery would be required for it. So if I compare almost, the comparison is 60 kg upon 4.5 kg. So here you can find out that it is almost like 45 and then 15 more. So it is almost 13 times. 13.33 times. So almost 13 times weight of battery is more. So even though we are having 4 times more of the conversion efficiency, the weight of battery is large for the case of electric vehicles. And this is the major challenge. So the challenge is majorly on the part of energy density. Energy density, it is for solid fuels, it is watt hour per kilogram. And for liquid fuels, it is watt hour per liter. And then we can calculate based upon the volumetric energy density and the gravitational energy density. We can compare the various types of fuels, that how much energy can be generated by 1 kg of the fuel or 1 liter of the fuel. So even if the electric vehicles are 4 times more energy efficient than the corresponding ICE based vehicles, that is internal combustion based engines, even though the efficiency is 4 times more, the weight of battery is almost 10 to 15 times more than the weight of fuel. So this is the major challenge that has been imposed on the part of electric vehicle. So here now I think when we are computing the cost of fuel, like for buying the petrol, the rates are very straightforward, that we have the petrol rates nearly 100 kg per liter. And on the part of that, the every model has been well worked out, the how much is the taxes and how much is the state tax and the central government tax. So everything is clear. But what about the battery? So how to compute the cost of battery? So here, like cost of fuel, it's not the cost of charging the battery alone. So cost of charging the energy is one, but the battery depreciates. In the ICE based vehicle, fuel tank never depreciates, at least for the life of one vehicle. So for the life of one vehicle, the fuel tank never depreciates. Here the battery depreciates, and therefore the cost of battery or the depreciation and interest, it also comes to the operating cost of the vehicle. So the cost of charging the battery, then how much cycles can be charged on that battery, then how much interest has already been paid for buying that battery. So including all these costs, so battery capital cost is almost around 12K to 15K per kilogram or per kilowatt hour for the small battery, and for the larger battery, it can be a little bit later, little bit small. So here, when we are computing the overall cost per kilowatt hours for usage, not only we need to include the cost of charging the battery, we need to include the fixed cost of the battery along with its depreciation and the interest. So that cost has to be included in the operating cost of the vehicle, and then only it would be the correct estimation. So we would be having much more discussion in the next lectures. I'm just pausing here in this particular lecture. We'll meet again in the next class where we would be discussing that how the various kind of models are available for computing the cost of kWh for usage in case of electric vehicles. Then why India is having so promising market for the electric vehicle. Everything that we are going to discuss in the next class. So thank you so much for giving me this patient hearing, and we'll meet in the next class very soon. Thank you.